All right. And change the camera. There we go. All right. Here we are. I'm not going to show you the work unless you need me to. Okay. Then you can ask at the end. Question number 1A. Your answer should be 1.1 times 10 to the negative 2 meters. 1.1 times 10 to the negative 2 meters. B is 7.62 times 10 to the negative 11 meters. C is 2.1 times 10 to the 3 meters. D is 1.23 times 10 to the 5 meters. 2A is 1.47 times 10 to the negative 1 kilogram. B is 1.1 times 10 to the negative 8 kilogram. C is 7.23 times 10 to the 3 kilogram. D is 4.78 times 10 to the negative 4 kilogram. 3A is 4.23 times 10 to the negative 1 meter. B is 6.2 times 10 to the negative 12 meter. C is 2.1 times 10 to the 4 meter. D is 2.3 times 10 to the negative 5 meter. E is 2.14 times 10 to the negative 4 meter. And F is 5.7 times 10 to the negative 7 meter. Do you need me to go over any of those? Okay, I'm going to finish this. Okay. Any? Yes, go. Yep, 2C. So in 2C, the conversion requires 2 steps because we have 2 prefixes, mega and kilo. So I'm going to look those both up. Mega is 10 to the 6th power. Kilo is 10 to the 3rd power. So I'm going to start by putting my given value over 1. And then I'm going to multiply by a fraction that will cancel out the mega. And as I mentioned, let me grab my pen so I can fix this. This should be 1 times 10 to the 6th power. So we can type it in properly. And then the kilo has to multiply it by the gram because these are multiplied, which means it's got to go in the numerator. So kilo in the top, 1 times 10 to the 3 in the bottom. Then you're just going to type 7.23 times 1e6 divided by 1e3. And that will give you this answer of 7.23 times 10 to the 3 kilograms. Anything else? Feel confident? You know what you're doing? Okay. You can use this to help you. You've got your reference table, your calculator in the SCI mode. You can go ahead and take today's quiz, which is in our Google Classroom. Go ahead and take that quiz now, please. Try to figure it out by Monday.
I will.
Okay, otherwise you're going to have to use the computer on your phone. Let me take these quizzes. When you've completed the quiz, we'll put our Chromebooks away. You will not need them for the rest of our class today. All you'll need today is your packet, your notebook, and your pencil. No calculators, no reference tables. Once you've completed the quiz. So all we need out today is our packet, our notebook, and our pencil. Please make sure when you are coming to class on Monday that you have a Chromebook that's fully charged. I will not be here for your class on Monday. I have to go have an MRI done. And the only time they could get me in was 1 o'clock, which is smack in the middle of our double period on Monday. So the way Monday's class will work, if I don't know who the substitute is, I'm only taking off your 2 class periods. So chances are that a substitute is not going to pick up my absence for the day. So some teacher in the high school or monitor is going to come in to make sure you're not destroying the classroom. That's pretty much what their job is. Okay. I will be pushing stuff out to you in Google Classroom to do. And what you'll be doing, there will be 2 videos posted. One for you for the period 8 class, one for the period 9. So that way we can keep going. I don't want your class to get behind my other classes. So those will be video recordings of me teaching my other 2 Regents physics classes. The same stuff that I would be doing if I were here with you. It's not like I'm saying, just go watch this video. Somebody else teaching this stuff out on the internet. It's me doing it the same way I'd be doing if you were here, if I was here with you live. It means that I know I said I'm going to give you a quiz on Monday. I'm going to push that quiz back to Tuesday just because I don't want a substitute giving you a quiz. The homework will be reviewed, and I will be checking that homework Actually, am I going to go over the homework on Monday? I don't think I am. I think I'm going to push it back to Tuesday. So you actually have till Tuesday to get the written assignment, which is page 12 in your packet done. But there will be another written assignment on Monday that's due Tuesday. So your best bet is to try to get this one done now over the weekend, and then the next one done Monday night for Tuesday. Okay? So I'm telling you to bring your charged Chromebook. If they can't get the video of me teaching up on here, because I don't know who it is, I can't give them the link to the YouTube video. Your Chromebooks don't connect to the projector, so each of you would have to watch the video on your Chromebook. Or you could pair up, and two of you could watch it at once. Just put the captions on the YouTube video. You know how to do that, so you can see the words at the bottom. I know you're not supposed to be wearing headphones in the building, but if you have wired earbuds that you can plug into the sound port on your Chromebook for this, that way you can listen to me talking. I don't know if you want to listen to me talk through the lesson. You can watch and just do it there. One of the things that we would be doing Monday if I was here, and what you're going to be doing on the video, is completing lab 1. But I do the whole thing on the video. So if you follow along on the video, you're just going to follow along and get it done the way I tell you to do in the video. Okay, and that's your assignment. If you don't finish it, you got to finish it for Tuesday. Okay, questions? Okay, then let's get going. Let's talk about algebraic manipulation, which is review of some things you did back in Algebra 1. For a lot of students who thought Algebra 1 wasn't horrible of a class, they actually like this. Other students who hated Algebra 1 are like, oh my God. They're like ready to run out of the room right now. But we do a lot of algebraic manipulation in this course. So what I'm going to ask you to do on Tuesday's quiz is solve 3 physics equations using algebraic manipulation to move the equation around for any other variable that's in there. What I mean by this is, let's say the equation was y equals mx plus b, which I'm assuming you've all heard that equation before. That's the equation of a line in slope-intercept form. It's solved for y. Y equals something. Move it around. Can you solve it for x?
Yes.
Okay, good. That's what you have to do in this lesson, is take any equation I give you and solve it for the other letters that are in there. So that way, that equation solved for y, you would get an equation for m, an equation for x, and an equation for b. So that equation actually leads to 4 equations. Okay, so that's what we need to know how to do. And that's what you'll be quizzed on, and that's what you'll be practicing for homework this weekend. So algebraic manipulation, as I just mentioned, is used to help us solve equations for unknown variables. And we do this in physics as we try to solve physics problems because it's easier to move around the variables without any numbers and units attached. What you will learn once we start doing some physics is that the measurements we work with, as you've seen, some of them can be really big in scientific notation. Some of them can be really small in scientific notation. And very often they have a bunch of units attached to the number. Trying to move those around as you're solving a problem and keeping them all together becomes really cumbersome. And most students make lots of mistakes if they just try to work with the numbers and the units. So instead, to minimize the mistakes we're making, it's actually easier to move them around without any numbers or whatever. Then you don't need a calculator till the very end when you just punch in your final stuff. So the way we solve an algebraic equation for these other symbols that are in there is we always use opposite operations to move them from one side of the equation to the other. So let's see if you remember this. What is the opposite of adding? Liam? Subtracting. Very good. What is the opposite of multiplying? Dividing. What is the opposite of squaring? It's taking the square root. Yes. So we're going to use these opposite operations to move something from one side to the other, which means if you're seeing the variable or the term being added into an equation and it needs to go the other side, you're going to do the opposite of adding, which is subtracting to get it to the other side. So what we're going to do now for the rest of our class period is practice this together. Practice, practice, practice. Some of you may be rusty doing this, and that's why I want to dust off the cobwebs, get you feeling good about doing this again. And I will tell you, if math was not your thing, by the end of this year, you'll be really good at it because we do it every day in every class. All right, you ready to work with me on this? Okay, so let me switch to my document camera. First thing I want to do is review the order of operations. In Algebra 1, I think they teach you something that you can say to help you remember the order of operations. PEMDAS, that's right. Now, what's interesting about this phrase, which stands for, I learned it as, please excuse my dear Aunt Sally, instead of PEMDAS. Either way, it means the same thing. It means that you would do parentheses first, then you do your exponents, then you're multiplying, dividing, and then you're adding, subtracting. This is the order of operations that you do with numerical values in a calculation. Which means when you go to your calculator to solve something, you have to do things in this order. Now, we're not doing the calculator stuff, so this is not what we're going to do. Instead, we do the reverse order for algebraic manipulation. And I don't think they teach you a mnemonic for that, so I made up my own. Put this in the reverse order, and you get SADMEP. SADMEP. This is the order of operations for the algebraic manipulation. Of an equation. Okay, so it's maybe this phrase will help you remember what to do in terms of solving your equation. Let's look at one example. Remember that equation I just listed off to you? Y equals mx plus b. I want us to solve that for another letter. You said you could solve it for x. Let's do it. Solve this for x. According to SADMEP, we have to undo any terms that are being added or subtracted first. The b is being added to that term that has the x, so we need to subtract it from both sides first. Now, I know a lot of you can probably do this in your head, but you remember yesterday we talked about that toddler who was crawling, and we want them to be able to run, and I want you to show the steps first to make sure you don't trip. Same thing here. Show the steps first. Eventually, I won't care. I just want you to get to the right answer, the right equation. But right now, I want to see it so I can help you if you're not getting it right. We can figure out where you're making the mistake, okay? So first thing we do is we subtract from both sides. So we end up with another version, y minus b equals mx. Now what am I going to do to keep the x where it is? Yep, divide both sides by m, which means that we end up with an equation for x that looks like y minus b over m. Everybody okay with that so far? All right, let's try another one. Now my hope is that you've seen this equation before, because years ago, the physics teachers met with the Algebra 1 teachers and said, here's a copy of our reference table with 3 pages of equations. Instead of you making up equations, how about you have the kids move these around? So that way, when you get to us, you've seen them before. I don't know, it made sense to us to try to help you in the future instead of just making an equation up out of the air. We're going to try solving this equation now, which is read as d equals VIT plus 1/2 AT squared. One thing you're going to see me do, my lowercase t's and my addition signs look different from each other. You see that? There's a reason why. Very practically speaking, if my lowercase t's and my addition signs look too close alike, I'm not going to know which is which. All right, so it's a good habit to start to make a lowercase t something like this versus a plus sign like that. I would like us to solve this for the VI, which is right here. Can we solve that for the variable VI? VI, it's V with a subscript I. So the first thing I have to do is undo the addition here. of the entire term 1/2 AT squared. Get rid of that. So now I end up with D minus 1/2 AT squared is VIT. Now, how do I get the VI by itself right here? We just divide both sides by T. We undo that multiplication. So we're left with VI is equal to D minus 1/2 AT squared over T. Now, in physics, you can leave that alone. In math class, your teacher might have said, simplify it. No, just leave it the way it is. Our job is not to simplify. Our job is just to get it solved for the letter that's there. And that's it. Okay. One more in here in our notes, and then we'll go to our packet to try another. Let's try manipulating the equation. VF squared is VI squared plus 2AD. I want us to solve this for the VI that's here. Again, I see an addition sign with this other term, so we are going to subtract the 2AD term from both sides first. So this leaves me with a new equation, VF squared minus 2AD is equal to VI squared. Now, I'm not done. I know the VI is by itself over here, but there's a square on it. I got to get rid of the square. What do you do to get rid of the square? Go ahead, square root it. So VI is the square root of VF squared minus 2AD. Now in math class, I think they make you put a plus or minus out front. Not in physics, because you can't have a negative value. You can't have a negative measurement in physics. So we don't put the plus or minus out front. And this can't be simplified any further because that is not a perfect square under the radical. Okay, that's where it is. That's done. Questions on this process? Is this ringing some bells? Remember doing this kind of stuff before? Great. Okay, turn to page 10 in your packet. We're going to look at a bunch more. Page 10 and 11 have 11 examples. I want to do 3 with you right now. And then I want you to try to do some with a partner. The 3 that I picked out to do with you are ones that have little tricks to them to get them solved. So I thought I would show you some little tricks. 1 through 5 are going to be solved for the letter R. In number 1, do you see where the R is? It's in the denominator of the fraction. You can't solve it the way it's written. You hear that? You cannot solve it for R the way it's written. You have to do something to it first. You have to rewrite the equation so it's linear without the fraction and the R squared in the bottom. So we're going to cross multiply. This leaves us with the equation FER squared is K Q1 Q2. Anytime the variable you want to solve for is in the denominator of a fraction, you got to do this. You got to get it out of the bottom first. Otherwise, it doesn't work. Now to solve it for R, we're going to divide both sides by FE. So that gives me R squared is K Q1 Q2 over FE. And then square root both sides. So that leaves me with a final equation that looks like R equals the square root of K Q1 Q2 all over FE. One thing we do need you to be careful about is make sure that radical sign is large enough that all of that is under the radical sign. It's not just in the numerator, the whole thing. Any questions on number 1? Okay, 2 through 5, I think you'll be able to handle now that I did that. Let's look at page 11. There's 2 of them on here I want to do. Let's look at number 7 first. And we saw this equation just a minute ago, but this time instead of solving for VI, I want to solve for A. I want to remind you of a couple things. You see this addition sign? Remember that addition is commutative, which means that 2 plus 3 is the same as 3 plus 2. So I'm going to reverse the order of these terms in the equation. The other thing I want to remind you about is that the half and the t squared are both multiplying A. Multiplication's commutative. 2 times 3 is the same as 3 times 2. So what I mean by this, I am going to rewrite this equation to look like D is half of t squared times A plus VIT. And now it's much easier to solve for A. Number one, because I see that I'm adding this whole other term to the equation, so I'm going to subtract the VIT from both sides first, leaving me with D minus VIT is 1/2 of t squared times A. And now what do I do to solve for A? Divide by the half t squared term. So that leaves me with an equation for A that looks like D minus VIT over half t squared. Do I have to simplify? No, I can leave it like that in a physics class. There is no reason to do anything more to it. So that's just a couple little tricks. Move it around, group things. It makes it easier to move things around so you can see what has to be added or subtracted. The last one I want to do with you is number 10, because this one a lot of kids mess up. You've seen this equation before, right? Pythagorean theorem, equation for the 3 sides of a right triangle. We want to solve it for A. First thing we're going to do is subtract b squared from both sides, leaving us with c squared minus b squared equals a squared. To get the a by itself, we take our square root. So c squared minus b squared under the radical is equal to a. Very often, again, I see a lot of kids try to simplify this and say it's c minus b equals a. And let's check to see if that makes sense. This is probably the most common right triangle ever. A 3, 4, 5 right triangle, where this would be side A, that would be side B, and that would be side C. My question is, does C minus B equal A? Is this the same thing? Well, let's plug in the numbers and see if that works. C is 5, B is 4, A is 3. Does that equal? No. So this is the final answer to the equation. Again, we don't have one perfect square under there, so we cannot eliminate the squares with the radical, okay? Questions? Okay, pair up. I want you to try the other problems on those 2 pages. Work with each other. If you and your partner are getting stuck, let me know. Just work with the person next to you. So Manur, why don't you work with Angela and Liam? Make a group of 3, okay?
Yes. This one. Yeah.
Bless you.
Oh, yeah.
If you and your partner both finish all of them through number 11, you can go ahead and work on the homework, page 12. Until everybody's ready.
I think so, yeah, because it's cumulative, so the 2 times the 3. Yeah. So,
Let's stay on task, please. Let's get these done.
yeah, let's see.
Almost done. You're not done yet.
Yes. But you can still. Is that what?
1:15. Okay. One more minute. We'll start to go over them. See, most of you are done. So. Yeah, next page is homework.
Like 16.
And again, I'm not going to check it Monday because I'm not here. I'll check it Tuesday. Okay, ready? Let's check it over. If you're getting things right, give yourself a star. So here is my solution for number 2, showing all the steps. I divided both sides by pi, this area of a circle. So I get a over pi is r squared, then take the square root. So r is the square root of a over pi. Number 3 is the circumference of a circle. I'm going to divide both sides by 2 pi, giving me c over 2 pi is r. Number 4, I got to cross multiply first. Get the r squared out of the bottom. So FGR squared is GM1M2. Then you divide both sides by FG. Then I got to take the square root of the r squared, giving me r is the square root of GM1M2 over FG. All right, number 5, I got to get the r out of the bottom. Cross multiply. ACR is V squared. Divide both sides by AC. And that gives me my equation for r, V squared over AC. How are we doing so far? Okay. All right, let's go to the next page, number 6. I rearranged it, then I subtracted the VI. Do you have to rearrange it? No. I'm doing that to try to make it a little easier for you to see why I'm adding or subtracting. So here's my subtracting VI, giving me VF minus VI is AT. Now I'm going to divide both sides by T, giving me the final equation, VF minus VI over T is A. Number 7 I did with you. Number 8. Again, I rearranged. And I grouped the 2 and the D together. So VF squared is 2DA plus VI squared. I'm subtracting VI squared. So VF squared minus VI squared is the 2D times the A. Now I'm dividing both sides by 2D, giving me A is VF squared minus VI squared all over 2D. Number 9, we're going to divide both sides by m. So F over m is equal to A. Number 10, I did. Number 11, I'm dividing the A by C, so undoing division is multiplying. So that gives me C sine theta is A. How'd we do? Good? All right, your homework is the next page. You're going to show your steps again, and you'll be asked to do 3 more on a quiz on paper. That next one will not be on a Chromebook, okay? Wow, we finished. My other classes did not finish, so